Hello. Today I present to you a new topic, that's error analysis. So what is error analysis sincerely? From the very title you can see that you are analyzing or you are studying different deviations from standard values, from accurate values, and that's what an error is. Yes. So what is an error in mathematics? An error, as I said, is a quantified deviation from an accurate value. And the accurate value can also be called the exact value. Yeah, and that these are some of the terminologies that we use in this area, in this part of applied mathematics. Then the value obtained with the error is called the approximate value. An approximated value can be the maximum or minimum value. For example, you may be measuring the length of something, or the length, let's say, of a container. Yeah, the length of a container, but you may find that you've under-measured or you've over-measured, and the result is maybe a faulty instrument or any other thing that causes you to make a mistake as you obtain that length of the container. Therefore, you may over measure or you may under measure, and that's how you obtain a minimum value or a maximum value. But in each of those values, they are deviating from what we call the exact value or the accurate value. And when you obtain that deviation and it's quantified, that's what we call an error in mathematics. Therefore, there are some terms to interact with in this part of the numerical analysis as a subtopic in applied mathematics. For example, absolute error, minimum value, maximum value, percentage error, relative error, and so on. These are just some of the terms that we interact with in this topic. So, yeah. This topic is really easy. As I can say, it's really easy. So what are the definitions of terms? Some of the terms. Yeah, of course, these are mathematical definitions. They're not going to say an error is this and this and this. It's because they're not going to ask you to define in words. You won't define in figures, in numbers. You're going to define numerically. So an error is the difference between the approximated value and the exact value. Then there's minimum value. That minimum value is the difference between the exact value and the error. Yeah. And then there is what we call the maximum value. The maximum value is the sum of the exact value and the error. If you remember, you're going to measure the exact value and you'd over measure, so you'd plus that error. That's that quantified deviation. Then you have what we call the absolute error. The absolute error is the maximum value minus the minimum value divided by 2. But you're going to see as we go on, there are some other ways this absolute error is defined. Yeah, but this is the standard definition. Then there is what we call relative error. Relative error is the absolute error over the exact value. Yeah, the modulus of the absolute error, the quotient absolute error of exact value. There's percentage error. Percentage error is simply the relative error multiplied by 100. Yeah, now for a given exact value, the possible error that can be made is obtained using a simple formula. That's a half times 10 power negative n, where n represents the number of decimal places of the exact value. So the error bound of a given exact value, let's say they have told you the height or the length of a rectangle for per se. Let's say the length of a rectangle, and they ask you what is the error that can be made in measuring this length. They've given you the exact value, so you do not know how which error, like you do not they have just given the exact value and they want you to find the magnitude of error that can be made in determining the length of the rectangle. So what you're going to do is you're going to use this simple formula, 0.5 times 10 power negative n, and n represents the number of decimal places on the exact value. If let's say the length they had given you, let's say if the exact value of the length is 8 centimeters, then n is 0 because there are no decimal places. But if let's say the length we were given is let's say 8.0, then n is 1. Yeah, n is what? N is 1. Therefore, you substitute in this simple formula and you'd obtain the error that you'd experience in measuring the length of the rectangle. Yeah, so this so far is the definition of these terms. Yeah, error, minimum value, maximum value, absolute error, relative error, percentage error. Yeah, and then the formula for the error bound. Yes, and error bound is sometimes you can call it error bound with an error. Yeah, you're going to see ahead that you're going to find delta, like delta L. Let's say if you're measuring length, delta L. Yeah, as I said, they gave you an exact value. They want you to find the error. What would you do? My God. Yeah, I was saying, what would you do? You'd have to use the simple formula 0.5 times 10 power negative n. Sorry about that. 0.5 times 10 power negative n. So that means you're finding the error, or you'd be finding what we call the error bound. Yes, these are just some of the other names they give to these terms. Yeah, so far we have seen the definition of these terms. Let's look at a question. Let's look at a question and we see how we are going to work about it. Let's look at the question and see how we're going to work about it. Yeah, the question says, if A is 1.50, B is negative 13.3, and C is 9.200, and they are all rounded to the given decimal places, find the minimum value of Roman 1, that A plus B over C, Roman 2, A minus B over C squared, and Roman 3, 1 over A minus 1 over B plus 1 over C. So what I want you to notice here is A, B, and C are given as exact values. They say they were rounded to the given decimal places. So these were the exact values that they have given you. Yeah, these are the exact values they've given you. So you're now going to have to find the error bound. So Roman 1 says A plus B over C. How do we find that? We have to obtain what we call a working value. So I didn't define this because we're going to see it in the questions that we're going to do. A working value, for a question like this one, the working value is you're going to evaluate what you are given, and then you're going to evaluate what you are given and you obtain the working value. You just substitute to obtain a working value. How is this helpful? It is going to help you to know. If, for example, I asked you for the minimum value, so it's going to help you to know how you're going to manipulate this information to obtain the minimum value, or how you're going to manipulate that information to obtain the maximum value. So for example, our working value is negative 1.2826. So if you obtain the minimum value, then that means you're going to get something more negative than the working value. But if you obtain the maximum value, then you're going to obtain something less negative than this working value. So that's how it's very important. So you find the error bound in each of them, A, B, and C. So delta A, delta B, and delta C, each is that. So now we're going to go ahead and find the minimum value in that expression, A plus B over C. What does that mean? How am I going to make this a minimum value? How am I going to make this a minimum value. That means the numerator has to be very negative. That means, okay, to make it a big negative, you're going to make the numerator a plus b a very huge negative, and c is the denominator, so you're going to make it very small. So remember, a quotient, the product of or the resultant from division is big when the divisor is small. So we have to make c very, very small so that we obtain a very huge negative. And we have to make a plus b as big as possible to obtain that big negative as our minimum value. So our minimum value therefore is, since we have investigated a is positive. So how are we going to make it? How are we going to make a small? Like when we're looking at making it the resultant very huge negative. Therefore, what we are going to do is we are going to minimize a, and we are going to make b more negative. You get, a is positive already, so you have to reduce that the effect of that positivity, and b is negative. You increase the effect of the negativity to make a huge negative. And c, of course, it is the divisor, so you have to make it also as small as possible. That's why you have a minus delta a plus b minus delta b over c minus delta c. So in substitution, that's what we get, and we end up with our minimum value as that. Then we move to part 2